Okay. So, again, this is out of Chapter 16, The Heart of Algebra, from our SAT book. But what we're focusing on right now is linear equations. So the entire section is linear equations, linear inequalities, and linear functions in context. Today, we're mostly just focusing on the linear equations in context. So, linear equations in context. So, most of what we're going to be doing in this section does require a little bit of word problems. Now, in order to do some of this, we have to have some background knowledge about some equations. So, a lot of times, a word problem will represent data using one of the most basic formats for a linear equation, which is slope-intercept form. You guys remember slope-intercept form? Mm-hmm. All right, so slope-intercept form is very important to us. And it is y equals mx plus b. Now, in that format, there's two main ideas that we have in that formula. There's the slope, and there's the intercept. Now, what intercept do you actually have in this format? The y-intercept, yeah. So, which value in here represents the y-intercept? The b. So, b is our y-intercept, which can be also written as a coordinate point as 0, b. All right. Now, the other value that's really important is our slope. Which value in there represents slope? M. So m represents our slope. And the important thing, there's a lot of different ways to talk about slope. If we're talking about it in terms of a graph, we're actually looking at slope as, rise over run, change in y over change in x. For what we're looking at right now with linear equations in context, we're talking about word problems. So most of the time when we're looking at slope, what we're really looking at is the rate of change. So rate of change is another way that you can talk about slope, because that's what it's doing. The rate of change. How much is your x value changing by how much your y value is changing? Because I said, again, slope is change in y over change in x. That's a delta symbol. It means change. So, again, when we talk about all these problems in context, if we're given an equation, we have to be able to recognize, what our y-intercept is, what our slope is. Now, other important things to realize about this. So, again, most important thing here was rate of change. That y-intercept in a word problem usually represents a starting point. All right, so another thing to keep in mind here for our y-intercept is that it's usually a starting value or starting point. Starting value or starting point. Now, again, anytime you're doing a word problem, if you're given an equation, you're able to look at that equation and identify, all right, I don't really know everything maybe about the equation, but I know that those two values, the m and the b, give me these important pieces of information. So if I see in a question a bunch of answer choices and they're talking about rates of change, so they're like talking about something per something else, and they use that word per, like so many units per year, or then that's a hint that, hey, we're looking at that rate of change, how much it's changing by per year. So that would be a hint that we're looking for the m value, right? We're looking for the slope. Or if they want to know in a money problem, you put so much money into account, it grows over time. Well, they want to know what the starting point is or what the principal value is. Principal is the starting amount that you put into the account. So that would be our starting point or our b value. So again, being able to identify those values by looking at an equation is very important when it comes to tests like the SAT or FSA or even PERT. Again, there's a lot of word problems on most of these tests. The PERT might have fewer word problems overall, but there's still quite a few word problems there, especially on SAT and FSA. Now, if you understand that part, again, most of the rest of this is pulling information out of problems. So I'm going to pass out a worksheet, and I want you to follow along with the worksheet, and we're going to go through a few problems. The rest of the problems that we don't do together is what I'm going to have you guys do in class. And again, they're not all going to be exactly the same because they're word problems. Every single one is a different situation. So some will be a little more straightforward. Some will be a little bit harder. So let me go ahead and pass this out. All right, so we'll build on the notes that we're taking today on your own sheet of paper tomorrow, because we do have to include things about inequalities. I tried to stay away from inequalities on this first paper, but what I did with this first worksheet, because we're slowly getting into word problems here, you'll notice that every question is almost repeated. So like, you see that you have question 13 up here. I'm asking a few things about it. And then down here, there's another question 13. And the same information is there. The question that is at the bottom of each of these sections is the overall, like that's the actual SAT question. I pulled those from previous SAT tests. So this one, I can't remember which test it came out of, but again, this is coming straight from your book that you have out of one of the tests that we'll take over the course of this semester. So in order to answer this question though, this is the type of information that you'd have to be able to identify about the problem. So I'm asking you some basic questions using the information, and then we're going to use it to find the correct answer. Now, some SAT questions, as you saw from the practice test, are multiple choice, some are not. So 19 is an example of something that's not a multiple choice question. I'd like to do 13 and 19 with you, and then the two that are on the back are going to be the two that I want you guys to practice on your own today. So we're going to take a look at number 13 here, and let me just get centered a little bit. So it says oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. Assuming that the oil and gas production decreased at a constant rate. Now, the first question that I'm asking you guys is, how many millions of barrels were in 2009? So, I think I made a typo. Hold on. How many millions of barrels are there in? That is a typo. Sorry. I need to double check change that to a 0 for me. My bad. That was a typo. Hopefully that's the only typo on this whole worksheet. All right. How many millions of barrels were there in 2000? Now, for this question, all right, we need to know a starting point. And in the information up there at the top, they gave us that starting point. So in 2000, what was the number of barrels? What was it? 4 million. Yeah, all right. So we had 4 million barrels. Now, that's important to us because we know that that's our starting point. If we're associating this with an equation like we were just talking about a second ago, that number could represent what value in that equation? So if 4 million is our starting point, that would be our y-intercept, which would be our b value in the equation. It's our constant, the one that's by itself. It's not being multiplied by a value. All right. Now, go to the next question. What is the rate of change for the number of barrels per year? So, on here, in order to see the rate of change, we need to compare the different values. Well, let's see. It dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. All right. So how much did it drop by? So the change in millions of barrels, we went from 4 million to 1.9 million. So 4, and again we went down to 1.9, so minus 1.9 for a difference of what? 2.1. Now, how many years have gone by? So this is the change in the number of barrels. How many years have gone by? So we went from 2000 to 2013. So there's a difference of 13 years. So this is the number of barrels, right? This is, sorry, that's the amount per barrel, and this is the number of years. Now, it wants to know an actual rate, though. So the number per years, what is that rate of change? Well, we got the 2.1 over 13. Now, this value here, it's not really proper to leave a decimal in a fraction. So, anybody have a good way of changing this so we no longer have a decimal in it? Okay, so here's another skill that you should be familiar with. In order to move a decimal, you're multiplying by increments of 10, or values with 10. Something with a 0 at the end of it. That's going to move your decimal, right? So here, in order to get this top one to be a whole number, I could multiply that top number by 10. So if I do something to the top, though, I also have to do it to the bottom, because I don't want to change the value of the actual fraction. So now, on this problem, it's 210 over 130. Sorry, not 210. 21. I moved it 2 decimal places. My bad. I'm entitled to a few mistakes every now and then. That's 2 for today. Alright. Sorry. Move it 1 decimal place. So 21 over 130. Now, that's our rate of change. Is the rate of change positive or negative? Well, I don't have a negative value here right now the way I did it. But let's think about it in terms of the problem. Was it increasing or decreasing? It was decreasing, right? So if it decreased, then my rate of change should be negative. So I need to go back and make sure that on this problem, when I did my rate of change, it should be negative. So the values that I have so far, I have 4 million as a starting point. I have negative 21 over 130 for a rate of change, because it's a negative rate of change. And then for part 4, what would be a good variable to use as your input variable, your x? So we had x and y in our original setup for our slope-intercept form, but when it's as a word problem, they're not always going to leave it as x and y. They're going to use variables that represent the data. So what number, or what letter, I should say, what letter could we use in place of x? So this is happening over what? What was it? Time. So time we could represent maybe with a t. So t for time would be a good thing to input into the equation, because we're looking at the number of barrels it's changing by over time. So using that information, we can now answer the actual SAT question. So we have all the information we need. We have starting point of 4 million. We have the rate of change is negative 21 over 130. And we're going to use an input of t for the time that's passed. So now look down at the question, because on the original information, I cut off the final question for the SAT. All right, I stopped at this point here. The final question now is, which of the following linear functions, F, best models the production in millions of barrels, T years after the year 2000? So, all the information that we need to answer this, we already have. So look at those answer choices. What stands out to you as one of the biggest differences in those equations? Because they're all set up in slope-intercept form. Look at your slope or your rate of change. Are all of them positive and all of them negative? No. So again, that's another thing you want to keep in mind when you're taking a test. If you're taking something like the SAT, that's all multiple choice, or on the FSA, quite a few of them are multiple choice. PERT, again, they're mostly multiple choice. On here, we can narrow this down by eliminating anything that had a positive value, because we know the slope should be negative. We know it should have a negative rate of change. Now, looking at these two, which one has the correct rate of change? C, right? We had 21 out of 130. So C, and if you double check the last value as well, it had a starting point of 4 million barrels. So 4 was the value that we were starting at. So C is our answer choice. Now, if you didn't have answer choices here, you might have to be able to write an equation. Or for the SAT specifically, they would ask you maybe one of these questions. So if you're taking an FSA test, they might ask you to type in the whole equation if it was a free response. For the SAT asks questions that are just single numerical values for all the free response. So if they ask you a specific question about the equation, they'd have to ask you something like my question number 1 or my question number 2. For either, what's the starting point, or how many barrels were there in a certain year. So again, those are things that they could ask. All right, let's look at number 19. So a startup company opened with 8 employees. The company's growth plan assumes that 2 new employees will be hired each quarter every 3 months for the first 5 years. So, number 1, what is the starting value for the equation? All right, so it opened with 8 employees. So that's our starting. Now, what number represents the rate of change? So what value up there represents the rate of change? And this one's a little bit tricky.
3.
All right, you say 3. Why do you say 3?
It says every 3 months.
Okay. So, every 3 months, you say 2. What's the 2 represent? 2 new employees. Now, by yourselves, neither of you are 100% correct. Together, you guys have the solution, though. Both of those is part of the rate of change, because the rate of change is comparing 2 values, right? Your slope compares 2 numbers, your x and your y. You need 2 pieces of data in order to do a rate of change. You need a number per something else. Here, we're talking about the number of employees added per every 3 months. Now, there are multiple acceptable ways to write this, because in this case, if we're talking about monthly, we could say that there are 2 new employees for every 3 months. So we could do something like 2 employees per 3 months. If you wanted to change it to a decimal, you could. If you divided this, then you get the number of employees per month. Or you could decide to change this to out of a year. And you could change this to, there's 12 months in a year, so you could multiply both of these numbers by 4 and say how many employees are adding each year. So it's going to depend on the final question as to, are we talking about monthly? Are we talking about every quarter? are we talking about yearly? So we need to wait and see in the final question at the end how they're going to want this represented. Now, what is an equation that will represent the company's growth? Again, this depends on how they want us to write an equation. Let's go back up to the information. So it says for the first 5 years, right? So it leads me to believe that we want an equation that might be yearly. Now, I'm going to go ahead and take a peek down here as well and see what the final question is, because I haven't asked the final question yet. But it says, if an equation is written in the form y equals ax plus b to represent the number of employees y employed by the company x quarters after the company opened, what is the value of b? So, there's a lot of information there. But they're actually saying that they want this based on the number of quarters. Well, 3 months is a quarter of the year. So the rate of change that we currently have can stay just like that. We don't have to do anything else with that. So now, what is the equation that will represent the company's growth? So let's go ahead and write the equation. We have, and I'm just going to use x and y to start off. So y equals, we have the rate of change. It's going to go up by 2/3 x plus our starting value of 8. All we did there was we took that format of y equals mx plus b, and we plugged in those two values. We plugged in our starting point for b. We plugged in the 2/3 for m. So now we have an equation. The only thing about keeping it as x and y is I don't know what x and y are. So in terms of this problem, we're looking at the x value representing the quarters within a year. So you might want to change this to something like E representing the number of overall employees. And you might want to change the x to something like Q for the number of quarters, if you left it this way. If you had written an equation that was a yearly equation, then we might want to have used Y for years and E for number of employees, or T for time would also work, same as we did in the last problem. So there's many ways you could set up this equation, but you kind of have to have a general idea of what this equation looks like to answer the question. So now, what does the rate of change represent in your equation from step 3? So I asked this question on 4 because I said there's multiple ways that you could have done this equation. The way that we have it right now, the rate of change is the change in number of employees per quarter, because we looked ahead. We looked at that final question. So the number of employees added per quarter. Right. So now, you'll notice again, the final question, which I already drew your attention to, there were no answer choices there. It's not an A, B, C, D type question. The final question is just asking for one specific value. Now, any of these things could have been a final question, right? If they had asked this as a final question, then we would have had to have answer choices. If they had asked one of these two, then it could be free response like it is, or it could have also been a multiple choice question. If they asked something like the last one, they could have given us an equation and asked based on the data, what does it represent? So you know how I said we could have written this equation several different ways? They could have given us this equation, or they could have given us an equation based on a yearly figure, and then said, all right, what is the y-intercept or the starting point of that equation represent? So they could have done this many different ways. But on this one, they're just asking for, notice, they say, in this format, what is the value of b? very simple question. Not every SAT question is going to be very high level. So, in fact, on this one, out of all those questions that we did, the answer that we did all the way back on the very first question that I made is actually the answer for this SAT question. It's not always going to be that simple, but some of them are. So again, you have to make sure that you are identifying what information you need to know. But again, you also have to make sure you read the question and see, maybe it's already given to me. Because for that first question, I didn't need anything else. I just had to read through the problem. All right? So, and just taking a look at this, this is the same thing I want you to do with the remaining questions on here. I want you to look at the information that's given, try to break it down with the questions that I gave you for 1 through 4, and then try to answer the final overall question on the bottom. Again, they're a little challenging, some of them are easy. So again, take your time. We don't get out here until 9:30. Wait, 9:31? Yeah, 9:31. So again, you have the rest of the class period to work on this. I'm not going to check it off until tomorrow morning. But again, it's just these couple problems. So a total of 10 problems. 5 of that one question, 5 from the other question. And if you want to help each other out, you can. So